Hello! Okay, so the purpose of this video is to show you how to graph polynomials. Generally what we're going to do is we're going to create a rough sketch of what a function looks like without actually having to graph it on Desmos. Okay, so the first step, what you want to do is you want to identify any x-intercepts or zeros. They are the same thing. The next step that you want to do is you want to choose x values between certain intervals to see if the y value is positive or negative. I'll go into detail what that means. And then the last step, what you need to do is you need to sketch the graph. Now, if you do calculate a positive y value, that is going to be above the x-axis. And if you calculate a negative y value, that's going to indicate that you're below the x-axis. Okay, so without further ado, let's go ahead and begin. Okay, so let's say I give you a function and you have to graph something like this. So y equals, and we have x squared times x minus 2 times x plus 6. Okay, so what I'm going to do is, well, first step that we want to do is we want to identify any x-intercepts or zeros. So the one way that we can do that is we can set y equal to 0, if that makes sense. So setting y equals to 0, that will tell us where our x-intercepts or zeros are. If you guys remember how to do that, one way that we can do that is we can set each of these factors that you see here, here, and here, we can set that equal to 0. So we get x squared equals 0, we get x minus 2 equals 0, and we get x plus 6 equals 0. Now, if we were to solve for x, take the square root of both sides here, and then you get x equals 0. Add 2 to both sides here, you get x equals 2. Subtract 6 on both sides here, you get x equals a negative 6. Okay, these right here are our x-intercepts. Okay, x-intercepts or zeros. Okay, so now what we're going to do is we're going to go ahead and graph. Okay, so here's a little graph here. We're going to create a very rough sketch. Okay, the important thing about this is the y values don't really matter. It's the x values that really matter. Okay, so I'm just going to graph some things here. So it's going to look something like this. 1, 2, 3, 4, 5. Okay. Oh, maybe we need one more. We need up to 6. Okay. Actually, hold on. Sorry about that. I'm just being a little bit picky about this. Okay. Hang on there a little bit. Okay, so I'm going to extend this. And then we have 2, 3, 4, 5, 6, 7. Okay, that's fine. Okay, so what we need to do is we need to take these x-intercepts that we determined earlier, and we need to plot them on our graph. So we're going to plot x is 0, we're going to plot x is 2, and we're also going to plot x is negative 6. So 1, 2, 3, negative 3, negative 4, negative 5. This is negative 6. Okay, so what we need to do is we need to test values in between each of the intervals. So we have intervals, let me put that in different color. We have intervals here, right? And then we have an interval here. We have an interval here. And we also have an interval there. Okay? So what we need to do is we need to go ahead, and that's step 2. Okay? Step 2 says we need to choose any x values within those intervals in order to see if our y value is positive or negative. So let's go ahead and try that. So what I see is, well, choose a number, any number that's less than negative 6. Well, let's try negative 7. So we're going to take this here, and we're going to just see what our y value is. Actually, we're going to take this. Okay, so we have negative 7 squared. Let's try. So we're just trying x equals negative 7. Okay, so negative 7 squared times negative 7 minus 2 times negative 7 plus 6. Okay, so negative 7 squared is going to be 49. Negative 7 minus 2 is going to be negative 9. Negative 7 plus 6 is going to be negative 1. The y value doesn't really matter. It's not the big deal about the actual value of it. It's more that we're trying to figure out in step 3 or in step 2 here is like, is it positive or negative? So all you're really doing is you're looking at the signs. So two negatives here become positive. So this means that this interval that contains negative 7, when x negative 7, y here is going to be positive. Okay, so what that means is when we go ahead and do this, so yeah, so this is greater than 0. So in other words, yeah, y is greater than 0 in this case. So that means this interval where that contains -7, it's going to be somewhere here maybe, and I'm not sure where. But anyway, that means the graph is going to go up. Okay, graph is going to go up. Okay, now let's try a different number. So we want to try a number now that is between -6 and 0. Let's try -1. So let's try, we're going to use this function here. Okay, and I'm going to solve for y. So -1 squared times -1 minus 2 times -1 plus 6. -1 squared is going to be 1. -1 minus 2 is -3. -1 plus 6 is going to be 5. Like I told you earlier, it's not very important to know where exactly the y value is, but of course, if you look here, the y value is negative. This is less than 0. So if the y value is less than 0 in this case, this means that this interval that contains x equals -1, so the interval that contains x equals -1 is going to be below the x-axis. So it's going to look something like this. Okay? Then what we need to do is we need to test more points. So going and testing more points. Choose any number that is, well, between 0 and 2. So let's choose 1. 1 is nice, right? So we're going to try x equals 1. So we try x equals 1 here. We have 1 squared times 1 minus 2 times 1 plus 6. This is 1 times -1 times 7. So as you can see here, we have a negative here. So because we have a negative that you see there, that's going to imply that when you multiply this out, this y value is going to be less than 0. Since that y value is going to be less than 0, this is going to be under. So it's going to look something like that. Okay? Then we need to go ahead and calculate the last value. So last value, as I see here. So this one on the side here, on the right, this is going to be, this is the values that are greater than 2. So let's try 3, right? So we tried 3 squared times 3 minus 2 times 3 plus 6. 3 squared is 9. 3 minus 2 is 1. 3 plus 6 is 9. Hey, like I mentioned earlier, not really important to actually calculate the exact y value. All you have to know is, well, is it positive or negative, right? So in this case, well, this y value is positive. It's greater than 0. Since y is greater than 0, that means when x equals 3, in this case, this is going to be above the x-axis. So it's going to look something like this. Okay, so that is generally, this thing here is generally what your graph is going to look like. Okay, all right. I'm going to stop here and I'm going to give you another example. Okay, bye. Hello. All right, more examples. Okay, so let's say I give you something like this now. And let's say we're trying to figure out, well, how do we graph it? So start off with step 1 again. Step 1, we're identifying x-intercepts or zeros. So what you got to do is you got to set y equals to 0. So if you set y equal to 0, you get 0 equals x times x plus 2 times x minus 3. Next, what we want to do is we want to calculate solve for our x-intercept. So we take each of these factors here and we have to set them equal to 0. So we get x equals 0, x plus 2 equals 0, and we get x minus 3 equals 0. Solve for x, we get x equals 0. Subtract 2 to both sides, we get x equals -2. Add 3 to both sides, we get x equals 3. So these right here are our x-intercepts. Okay, now what we're going to do is we're going to go ahead and try to see if we can graph this. Okay, so to graph it, so what we have is we need something. So 1, 2, 3, 4, 5. Maybe 1, 2, 3, 4, 5. So this is what our how we would kind of graph this. Okay, so we know that one intercept is at 0, one of the intercepts is at -2, and one of the other intercepts is at 3. Okay, so what we want to do is we need to, again, now we need to figure out interval. If the intervals are going to be above the x-axis or below the x-axis. Okay, so what we're going to do is, well, we got to choose a number that's less than -2. Let's try -3. Let's try x equals -3. You could try -4. You could try -100. Whatever you want to do. Let's try -3. Again, this part is just ambiguous. You can choose any value as long as it's within that interval. So if I were to go ahead and plug this in, so this is -3 times -1 times -6. Yeah, okay, so as you can see here, oops, I forgot the parentheses. So we have a negative and a negative and with a negative. So three negatives will, well, two of them are going to cancel out to become positive. And what we know is that this value is going to be less than 0. Since this y value is going to be less than 0, that means when x is negative 3 over here, the y value is going to be less than 0. So what that's going to imply is that this graph is going to come down. It's going to look something like this, wherever that point is. I don't know exactly where that point. Maybe it's there. Okay, now I'm going to go ahead and erase. Okay, now we need to choose more values. Okay, so choose a value between negative 2 and 0. Well, negative 1 looks like a nice number. Let's try negative 1. So if we tried x equals negative 1, so we have negative 1 times negative 1 plus 2 times negative 1 minus 3. So we get negative 1 times 1 times negative 1 minus 3 is negative 4. Now when we get to this here, we have two negatives. They become positive. So since the two negatives become positive, well, this value is going to be greater than 0. Since y is greater than 0, this implies that this is going to be above the x-axis when x is negative 1. So something like this. Come up, and it's going to come back down. Okay. Now we got to try more values. Now we got to choose values between 0 and 3. So let's say we try, well, looks like 1 is between 0 and 3. Let's try 1. So if we take this here, we're gonna go ahead and take that function. So we have 1 times 1 plus 2 times 1 minus 3, and we have 1 times 3 times 1 minus 3 is negative 2. And again, as you can see here, well, this is negative, so this is less than 0. So what this means is, well, since the y value is less than 0, and we have x is 1, that means the graph is going to come down. It's going to be something like that. Okay? Last one that we need to do, we need to go ahead and figure out the interval, this last interval. Okay, so well, choose a value that's greater than 3. So maybe 4. Let's try 4. So if we try 4, this is 4 times 4 plus 2 times 4 minus 3. So what we have is, if we calculate it, 4 times 6 times 4 minus 3 is 1. So again, like I mentioned earlier, doesn't matter what the y value is, as long as you go ahead and see that, well, this value is going to be greater than 0. So as you see, this x equals 4, when x is equal to 4, y is going to be above the x-axis. So that means it's going to finish off, and it's going to look something like this. So this is generally what our graph would look like if you are given something like that. Okay? All right. Okay, so next I'm going to show you another example. Okay, so just going to go ahead and erase some of the things that you see there, and I'm going to continue. Okay, so let's say I change up the problem a little bit, and I give you something like this. I really should have just cleared the screen. Negative x plus 5 times negative x, x minus 7 and x plus 1. Okay, same idea. What we want to do, start off with step 1. Step 1, identify any x-intercepts or zeros. So we're setting y equal to 0 in order to find our x-intercepts. Okay, so 0 equals negative times x plus 5 times x minus 7 times x plus 1. Now, something interesting happens here. So you see the negative here? Whether we divide, if we divide this whole thing by negative 1, it's still 0 on the left-hand side. So it doesn't really make a difference if we want to solve for x-intercepts. If we want to just solve for x-intercepts, we can just take the factors that you see right there. Okay, so let's go ahead and take our factors. So x plus 5 equals 0, x minus 7 equals 0, and we have x plus 1 equals 0. This one, subtract 5 on both sides, x equals negative 5. Add 7 to both sides, get x equals 7. Subtract 1 to both sides, get x equals negative 1. These right here are going to represent our x-intercepts. Okay, step 2, now what we want to do is we're going to go ahead and try to graph it. Okay, so if we try to graph this thing, well, one of our x-intercepts is going to be at negative 5. Another x-intercept is going to be at negative 1. And our other x-intercept, 1, 2, 3, 4, 5, 6, 7, is going to be at x equals 7. Okay, so what I see, again, what we want to do is just look at our original function, and we need to plug in values. So what I see is, well, we got to choose a value that is going to be less than -5, so we can try -6. So we have -6 plus 5 times -6 minus 7 times -6 plus 1. So this is going to be a negative times -1 times -13 times -5. We have four negatives here. Four negatives, they all cancel out and become positive. This interval is greater than 0. So that means when x equals -6, or something that's less than -5 here, this is going to be greater than 0. Okay, so what this means is that this value is going to be above the x-axis, okay? So that's the first part. Okay, next what I see is we want to choose a number that's between -5 and -1. Okay, so let's try -2. So we try -2. So negative times -2 plus 5 times -2 minus 7 times -2 plus 1. So this is going to be a negative times 3, and then we have, this is -9, and this is going to be like -1. So what we have is we have 3 negative values. So the 3 negative values, this implies that this value is less than 0. Since y is less than 0 for x is equal to -2, right? So as you can see here, the y value is going to be underneath. So when we graph this, this is going to be coming like this. Okay. All right. Okay. Now I need to erase some of the work here. I need to show you another example. Okay. So let's say I have something like let's see. So choose something between -1 and 7. Let's try 0. 0 might be nice. So if we try to plug it into here, right, we're going to get negative times 0 plus 5 times 0 minus 7 times 0 plus 1. And then we get -5 times -7 times 1. This, as you can see here, we have two negatives. They become positive. So in other words, this y value is going to be greater than 0. So since the y value is greater than 0, when x equals 0, it's going to be somewhere maybe here. That means this is implying that this is above the x-axis. So this whole interval, when you calculate it, is going to be above the x-axis, something like this. Okay? All right, and now let's go ahead and finish this up. Okay, so I'm just going to go ahead and erase some of the things here. And now we have to choose a value now that is greater than 7. So let's try 8, right? So negative times 8 plus 5 times 8 minus 7 times 8 plus 1. So this is going to be -13 times 1 times 9. We have a negative here. So since we have a negative here, the y value is going to be less than 0 when x is 8. So that means it's going to be somewhere down here. That means when we graph the function, it's generally going to look something like this. Okay, if this is y and this is x, our graph is going to look something like that. Okay, all right, let's go and do one more example. Okay, so I give you something like this. So y equals negative x times x minus 3 squared times x plus 1. Okay, now same idea. Step 1, what we need to do is we need to identify x-intercepts. So set y equal to 0 in order to solve for x-intercept. So 0 equals negative x times x minus 3 squared times x plus 1. Okay, so next what we need to do is, like I told you earlier, we're going to divide by the negative. It doesn't matter. If you're just solving for x-intercepts, we need to get each of these here and set equal to 0. So we have x equals 0, we get x minus 3 squared equals 0, and then we get x plus 1 equals 0. Okay, so this one is, well, obvious. This is given. This is x is 0. If you take the square root of both sides here and then add 3, you get x equals 3. Then if you subtract 1 on both sides here, you get x is negative 1. Okay, so now what we need to do is we need to try graph it. So if we try to graph this thing, it's going to look something like this. Let's see. So we need up to maybe like 4 here, and then maybe we need to go down, maybe at least like 3 or something. Maybe that's all we need. So we know that one intercept is going to be at negative 1, the other one is going to be at 0, and the other one is going to be at 3. Okay, so next what we need to do is we need to choose values in order to try graph approximate this the graph of this function. So let's choose a value that's less than 1. Let's try -2. So we try -2. So we have negative times -2 times -2 minus 3 squared times -2 plus 1. So as you can see here, this is going to be -2. This is -5 squared, -1. This is negative times -2. -5 squared is going to be 25, and then -1. So as you can see here, well, we have three negatives. Three negatives here. This is less than 0. Since y is less than 0, what for x, do we try? Yeah, -2. So this one here, that means y is going to be below the x-axis. So it's going to come down, and it's going to be maybe somewhere there. So that's what it's going to start off as. Okay, now we have to choose a number between -1 and 0. So if we try between -1 and 0, well, let's try -0.5. Well, I think that's between -1 and 0. So let's go ahead and try that. So we have a negative times -0.5 times -0.5 minus 3 squared minus -0.5 plus 1. Then when we do this, this is negative times -0.5 times -3.5 squared plus times 0.5. Okay, so now this part here, if you wanted to, yeah, so actually if you can see here, this is going to be positive. Anything squared, negative times negative is going to be positive, but I'll just do the math for you. I'll just do it real fast. Hopefully I don't mess up. Carry the 2, and it's going to be something like that, and this is going to be like that, and then 2. So I think the 2 decimal places, this is going to be 12.25. Not that it really matters, it's still going to be positive, right? 12.25 times 0.5. As you can see here, 2 negatives will become positive anyway, right? This is greater than 0, so this means that at x equals -0.5, y is greater than 0. So this part is going to be above the x-axis. That's all we need to know. We need to know that that part was going to be above the x-axis. Okay, let's do a few more. So what we have here, we need to choose a value between 0 and 3. Let's try 2. Let's try 2. So if we plug 2 into here, so we have something like this. Okay, so we have -2 times -1 squared times 3. -2 times 1. -1 squared is going to be 1 times 3. Okay, so when we get to something like this here, so we have a negative value. Negative value, we know that this y value is less than 0. So what that means is, well, when x is 2, the y value is going to be less than 0. So this means that this interval is going to be underneath the x-axis. So something like this. Okay, and then let's do one more. So what we have is we have something, we want to choose something that's greater than 3. So let's try 5. If we try -5 times 5 minus 3 squared times 5 plus 1. So -5 times 2 squared times 6. -5 times 4 times 6. Now, as you can see here, this negative here is going to imply that this is going to be below the x-axis. Okay, so because we have this is less than 0, since y is less than 0, given that we chose x equals 5 to begin with, so this y value is going to be below the x-axis. So something of this form. It's going to look something like that. All right, and that is what your graph looks like. It's a general idea of what your graph looks like. Okay, great. I'm going to continue in the next video really soon. Okay, bye. Hello. All right, so let's continue where we left off. So let's say I ask you a question like this. So as x approaches a really large number, so for example, this is the x-axis, this is the y-axis, right? So as x gets really large, so as we're going this way, what's happening to the y value? So as this goes further, as x is really large, what's happening to y? So as you can see here, just based off this little description that I kind of showed you, y is getting really large, right? So yeah, so you can just say, yeah, in this case, this would be, well, the y value approaches a large positive number. Yeah. Or in other words, as you guys will probably see later, is that the way you express this in notation is y is going to approach infinity. So it's approaching a really big number. Okay, now let's say I ask you the opposite. So now, as you can see here for this graph, well, as x gets really, really big here, well, if x gets really big, what's happening to the y values as it gets really, really big? Okay, so to answer this particular question, well, it's going to be the opposite. Well, where do you think the y values are going? Is it going up towards positive infinity, or do you think it's going to go down? So this would be an example where this would be like, well, the value, so the value would become more negative, right? I'll just put negative, right? Because as x gets really large, the y value is getting further more and more negative. So in other words, in math notation, this is denoted as y is approaching negative infinity. So that's what that would look like. Okay. Now, last thing that I also want to present is this here. So as you saw, we've had functions that look like this, and we've had functions that look like this. Okay. So these are called odd functions. Okay, these are called odd functions. So, like this would be something of the form, maybe like this is like y equals x cubed or something, and this would be like y equals negative x cubed. The reason why it's flipped the other way is because, well, the graph is just kind of flipped over the x-axis. So that's what that implies. The way you can tell it's odd is the degree. And I'll show you, and yeah, so if you kind of consider the degree of the polynomial, then that can tell you whether you have an odd or even function. Okay, now let's say we have something else. So another thing that we graphed, we graph things like this. We have w's, and we also have m's. Okay, so these are called even functions. Okay, an example of an even function, well, this could be something like y equals x raised to the 4th power, and this other one is going to be something like y equals negative x raised to the 4th power. So this would be, yeah, this is flipped across the x-axis, if that makes sense. So, and as you can see here, it's even because the exponent is even. So for example, if you look back at the examples that we did earlier, we have y equals x squared times x minus 2 times x plus 6, right? So if I gave you something like this, right? So we have a degree of 2 here. This is the degree of 1. This is the degree of 1. So 2 plus 1 means that the degree of this polynomial is going to be 4. So that's why if you saw the shape of that particular example that we went over earlier, it looks something like that, if that makes sense. Okay, now let's say I show you another example. So one of the other examples that I showed you was something like this. So something like y equals x times x plus 2 times x minus 3. Okay, so you can see here, well, this would be like, this is the first power, this would be a first power, this is a first power. So if you just consider all those exponents, 1 plus 1 plus 1 is going to be 3. So that means the degree of this polynomial is going to be 3. So if the degree is, yeah, odd, as you can see, well, it's going to be an odd function. And as you can see, that's why that particular graph looks something like that. Now, if you played around, if you see the other examples that I showed you, the other example went this way because we had a negative in front, and that's a degree of 3. And then the other example looked something like this because, well, if you look at it, that's a degree of 4, and the negative sign, like I told you, makes a graph flip over the x-axis. Okay? All right, and that is basically my little thing on graphing polynomials. Okay, please let me know if you have any questions on this, and that is it. Okay.